All right, number 4 was very, I would say, kind of mechanical stuff. And so I'm hoping you'll earn lots of points on this one. Consider the curve. It can be shown that the derivative is that. So, a lot of times in a one of these, it says, it can be shown that, show the steps or prove that. It gives you the answer and you have to go through the implicit differentiation. This one, don't do more work than you need to. It says what the derivative is. You go with it. Write the equation of the line tangent to the curve. Okay, come on, you get these points. You need a point, which you have, and you need a slope. But your notation is a big deal. dy dx evaluated at 1, 1 would be what? Yes, I'm just putting that into this. So I have 1 over 3 times 1 squared minus a minus 1 or plus 1 there, of course. And so that ends up being 1/4. So you have your point, you have your slope. The equation of the tangent line then would be y minus 1 is 1/4 x minus plus 1. And that's my answer. You got 1 point for the slope, but y'all, if you don't have this notation, you would miss at that point. So your notation is big, and of course, plus 1 for getting the correct equation. Find all the coordinates of all the points on the curve, which line tangent to the curve is vertical. What do we know? I always like to write this down. Vertical tangent when what? When dy dx is undefined. Okay? Which means what? It means that the denominator can, the denominator is going to, dy dx is going to be undefined when the denominator equals 0. Now, here's something I see a lot on the answer keys, and maybe this is being picky, but the top does not equal 0. In other words, the bottom, you can't have 0 over 0. So even though that's just something I've seen a lot that you might want to put on there, I'm not sure if you get the point without it. You very well may, but it's when the bottom is 0, but the top isn't 0. So I would just kind of add this but in there. Okay, that's kind of funny. All right, so how do I finish this out? Well, when the denominator equals 0, what would be true? X would be 3y squared. I'm going to take this 3y squared, go back to the original question, and I'm doing it this way because it's easier than solving for y. I can do it 2 ways, but pick the easier way. I'm going to plug that in. Notice I have y cubed minus, I'm going to plug this in for the x is equal to 2. If I clean that up, that's y cubed minus 3y cubed. That's negative 2y cubed is equal to 2. I think you can see that leads me to y cubed is equal to negative 1. So y is equal to negative 1. And then I like to kind of lead this way. So if y is negative 1, once again, I'm going back to this original way up here. If my pen will write. Oh, no. Come on, pen. Come on, little fella. Boop, boop. Okay, there it is. That guy. And put in negative 1 for y. So negative 1 cubed minus x times negative 1 is equal to 2. And I can solve negative 1 plus x is equal to 2. Therefore, x is equal to 3. And then I write my answer. We will have a vertical tangent at, and my coordinate, making sure I do x comma y, is 3, negative 1. Here are the points. Did you set the denominator equal to 0? If you did that, awesome. Then, did you get this equation in one variable? So you knew to plug that in and you were able to write an equation in one variable. And finally, did you get down to a final answer of 3, negative 1? Oh, letter C. Evaluate the second derivative. Oh, good golly, Miss Molly. Okay, I've seen this one so many times. So the second derivative, they saved you a little time. Remember, the first derivative was this right here. I'm going to rewrite that so I can kind of look at it as I work. dy dx is y minus 3y squared minus x. So in order to do the second derivative, obviously I would have to do the first derivative first, but they gave you that. So I have to take the second derivative and do implicit on this guy. So here I go. Ho, bottom, d high, derivative of the high, dy dx, minus high times the derivative of the ho. Okay, power to the front, 6y dy dx, minus 1. So ho d high minus high d ho all over that whole thing squared. Ho ho. Okay. Now here's kind of the moment of, truth. Different people do different things. So you certainly have the opportunity to do this in different ways. But notice this. They're asking you to evaluate dy dx squared at, negative 1, 1. That's familiar. Look back at letter A. Okay, look back at letter A. You found the derivative evaluated at negative 1, 1. Learn to make your life easy. I like to plug in numbers from as soon as I can. Now, this one still gets a little, you got to be careful, but I'm going to plug in numbers. I'm going to plug this in for y. I'm going to plug in this in for x. And what is dy dx evaluated at negative 1, 1? That's what I did in letter A. It was 1/4. Okay, so that's what I'm going to plug in. So here I go. I have 3 times 1 squared minus 1 times 1/4 minus 1 times 6 times 1. I'm filling everything in so you're knowing when I can get these numbers. Obviously, I do some of this math in my head, but minus 1 all over 3 times 1 squared is 1 minus plus 1. Got to be careful. Squared. And what does that end up giving me? Okay, well, let's see what I have here. I think I put a minus when I should have put a plus. So sorry about that. I was just looking at that going, wait a minute, that's not right. I forgot that x was negative 1, so that's a plus 1. So I end up getting, what is that, 3 plus 1, so 4 times 4, or times 1/4, that's a 1, minus, what is all this business? That is 3/2 minus 1, that's 1/2, yeah? Times 1, so over that. And then on bottom, I really have 4 squared is 16. So, and really and truly, I could leave it right there. Remember, you can leave it right there. Y'all, to be honest with you, I could leave it right there. I could not, which that would be the smartest thing ever, is just leaving it literally there. You can stop right there if you want to. It ends up being 1/32 if you go kind of all the way. But smart thing is just to stop when you plug all the letters, all the numbers in. Now, somebody else would say, well, couldn't I have plugged dy dx back in? And yes, you could take this and plug in here and here. That just gets and then plug in your numbers. But again, I'm hoping that you can see how I save time by knowing that I already evaluated that at negative 1, 1. So what was the points? The points were, it was actually worth 4 points. There were 2 points for the implicit differentiation, which means if you were doing if you were doing the quotient rule and you were getting it almost right, you get plus 1. If you did the quotient rule, but you made a silly mistake or, put an extra dy dx or forgot one little dy dx or something, like it was almost right, then you would get plus 1 of the 2. If you weren't even doing the quotient rule or didn't put dy dx on anything, you probably wouldn't get any points. And then did you get a point for substituting in for dy dx, whether that means the value or you did put in this dy dx and then substitute into there. You got a point for knowing to do that, and then 1 point down for your answer. How did that one come out? That was a little bit better. That one was a little bit better, 3.59. And my guess, you could get some of those points, I hope. Good, good. Long video, but we love it. We love math. Yes, we do. Here we go. Let f be a function defined by this. I think this one is a little mechanical, but it does have a lot of good things, and that's why I picked this problem, because I was like, oh, this was good. This was good. So average rate of change of f. Average rate of change of f. Okay, so in other words, the AROC between 0 and pi. What's that the formula from? Well, remember, and I just, yes, I could go to the straight formula. Let me do what it is. It is f of pi minus f of 0 over pi minus 0. If you said, well, you said every time we do average, like circle what comes after it. Well, what comes after it is rate of change of f. So if I did the integral of f prime over the interval, I would have this. But just think how I would do that top piece. Well, if I integrate f prime, what do I get? I get f. So I would get f of pi minus f of 0 over pi minus 0, and that's the formula that I just said. So you could get to that formula a couple different ways. I just have to evaluate those things and be careful. So e of pi, I would have e of pi times the cosine. I hope you're okay with me doing this in my head. Cosine of pi is -1 minus e of 0 times the cosine of 0 is 1 over pi minus 0. So I would end up with negative e to the pi minus 1 over pi. People ask, could I leave it? Could I leave it as e to the pi times the cosine of pi minus e to the 0 cosine of 0 over pi minus 0? You actually can. So if you don't feel comfortable with the unit circle, you can actually leave it that way. You get +1 for the answer there. What is the slope of the line tangent to the graph at 3/2? So you're like, okay, I have to find the derivative and I have to put in 3/2. So I have to find f prime. That is a product, so I'm simply doing the product rule. First times the derivative of the second plus the second times the derivative of the first. Once again, and I could be really smart about this, f prime at 3 pi over 2, I literally could leave it this way if you don't feel good about the unit circle. Some people that's very hard to do, and I know for me it kind of is. But I would just have to think the sign is -1, so that's -1, so that's e to the, I'm just writing the answer in case you did it. You got to know if you have it right. Cosine of 3 pi over 2 is 0, so that goes away. So you end up with this as your answer. Okay, you get 1 point for getting a correct derivative and 1 point, however you left it, for getting the correct slope. Absolute minimum. Here we go again. Okay, you kind of did this on the calculator portion, I think. I feel like I did a problem this way. So again, it shows up everywhere. So what do I have? I have the candidates for the endpoints are candidate for the endpoints. Candidates for the absolute minimum are endpoints, and where f prime, and this is on a non-calculator part, so I can't really look and see where it's changing. I'd have to do a sign analysis. So I'm really not wanting to do that. So I'm just going to say where it equals 0. I don't want to waste time doing a sign analysis, seeing negative to positive. So let me see where that is. Where does f prime equal to 0? So let's look at that. If I look at this f prime, I've already found it. I might set f prime, and I'm just going to do a factoring step, if that's okay. I'm going to factor out an e to the x. Are you with me that I would get that? E to the x and then cosine minus sine. Where is that equal to 0? Well, e to the x can never be equal to 0. But where does cosine of x equal sine of x? I mean, isn't that, if you have cosine of x equal minus sine of x equals 0, that's really saying where does cosine equal sine? Well, on the unit circle, that would be here and here. So that's going to be x at pi over 4 and 5 pi over 4. So those are my candidates. My chart, let's see if I can fit that in right here. We have x and f of x. That's going to be a little gross to do, but it's all good. I have 0, I have pi over 4, I have 5 pi over 4, and I hate signing fractions, and I have 2 pi. What do we got? I've got to literally go back. I am plugging into f of x. So I'm going back up to my original right here, e to the x cosine of x. I'm just going to write that here so I can remember what it is. I'm going to plug that value in, and I'm just getting my values. So e to the 0, that's 1, cosine of 0, that's 1, so that's going to be 1. Pi over 4 would be e to the pi over 4 times square root 2 over 2. This would be e to the 5 pi over 4. The cosine of 5 pi over 4 is negative square root 2 over 2. And then 2 pi would be e to the 2 pi times 1. Now, what do you notice is that positive number, positive number, positive number, negative number. And I'm looking for a minimum. So I go, boom, there it is. And then I read again. Is it asking me where it is or what it is? Find the absolute minimum value. So I'm going to say absolute minimum value of f on 0 to 2 pi is, and what's the answer? Negative square root 2 over 2 e to the 5 pi over 4. My answer is very clear, and my grader knows I answered the question that was asked. What are the points? Well, did you set f prime equal to 0? Did you do that? And that's what's 1 point. Did you identify these two guys as candidates? Okay. And then did you get this answer? But remember, for getting this answer, all this stuff has to be there too. Last one. Let g be differentiable function such that g of pi over 2 is 0. The graph of g prime is shown below. Find the value of that or state that the limit doesn't exist. Justify your answer. Okay. Well, what do I have here? So you see a limit of a fraction. You kind of are guessing that it's L'Hopital's in a way. And so you can almost think, well, what is the limit of this? Now, and I probably would do it in my head. Did you not just plug in, if you plugged in pi over 2 into f, think about what that would be. Way back up here, e to the cosine. Isn't the cosine of pi over 2 0? So are you with me that that one is going to be 0? And the bottom, it kind of told you that g of pi over 2 is 0. So you have that. Now, here is something that, gosh, they're going to be picky on. Remember, I want to emphasize the L'Hopital's notation. This one has one other thing that I'm not 100%. If you didn't say it, you wouldn't get credit, but I know that they're picky. So here we go. Can I know that the limit as x goes to pi over 2 of f of x is 0? That's something I have f of x way back up here. I even found, I know that that's a continuous function because I know e to the x is continuous and cosine is continuous. So I know that. And so that limit would just be, it would be 0 because I would just plug in 0. Now, the thing about g is, this is the part that I'm not 100% if you would have to say it. They told you that g is differentiable. When the limit equals the function value, that's only true if you have a continuous function, right? I could look at f of x and know it's continuous. For g, I don't know if it is or not, but they told me it's differentiable. So if g is differentiable, then g is continuous. Now, why does that help you? Because if g is continuous, then the limit, sorry, this is terrible writing here. The limit as x goes to pi over 2 of g of x is going to be equal to the value of this, which is 0. That is only true if you have a continuous function. So that's not always true that, the limit and the function value are the same. That's only true if g is continuous, but you know it's continuous because it's differentiable. Let me finish writing the L'Hopital's part. Okay, so since those limits are equal to 0 by L'Hopital, the limit, and I like to rewrite the question, the limit of this is going to be equal, make sure you're writing the limits, the limit of the derivatives and where do I get those numbers? Well, how do I get those numbers? Okay, well, I know what f prime is. Remember, way back up here, I'm going to refer back. Way back up here, I found the derivative f prime. So what would I get if I plugged in pi over 2? Well, I'd have e. Let me just, I'm doing a lot in my head. I hope that doesn't mess you up. I got to go back up here because I got to look what the derivative is. I've forgotten. So I'm doing e to the pi over 2 times the negative sign of pi over 2. That's negative 1 plus, the cosine of pi over 2, that's 0. So that place is going to go away. So I get negative e to the pi over 2. Now let's look at that bottom part. What do I get for him? Well, this is the graph of g prime. So how do I find the limit as x goes to negative pi over 2 of g prime? I am going to look at this graph of g prime and ask myself, does the left-hand limit equal the right-hand limit? Does that equal? Yes. When I come in from the left and I come in from the right, I go a y value of 2. And so that is my final answer. I can leave it like that or clean it up. And there you go. So what are the points? Well, you get 1 point if you talk about these limits. Here's the part that I'm not 100% is if you didn't say this part, would you get that point? I honestly don't know the answer to that. Again, you have to justify with the given. How did you know that this limit was equal to this? So my guess would be no, and I like to error that way. So yeah, you get 1 point for that. You get 1 point for applying L'Hopital's rule. So knowing that it would be this, again, you have to have the limit words there. If you don't have the word limits, they stop looking, even if you have the right answer. And then did you get to the right answer there? Okay. The average score. I'm doing a lot of talking. My throat's getting sore. 2.59 on that one. Okay, a lot of good things. Notation for L'Hopital's, another absolute, max min, always on there. And so many good things. All right, last one. I think I can do it. My voice is going to hold out. I just know it. Popular second fundamental theorem. Let f be defined by the function from 0 to 7. The graph of f consisting of 4 line segments, let g be the function, and g of x is a function defined with an integral. Here we go. Find g of 3. Come on. You're going to get all 3 of these points, I hope. So again, look at my notation. G of 3. What do? You got to defend with the given. How did you know what to do? I'm going to take the integral from 2 to 3 of f of t dt. This is my picture of f. Okay, from 2 to 3, that's a trapezoid. So what is that? That's 1/2. The height is actually 1. And base 1 is 4. Base 2 is 2. And I get a value of 3. G prime of 3, what is that going to be equal to? Well, remember, here we are. If g of x is a function defined as an integral, then g prime is going to be equal to replace with the upper bound times the derivative of the upper bound. So isn't g prime just going to be f? So g prime of 3 is just f of 3. I'm looking at my graph. I'm looking at a y value, and I'm putting 2. And so g double prime of 3 is going to be f prime of 3. And I'm then just going to find the slope. I'm going to erase so you can see. I'm just going to find the slope at 3. And I'm just going to count. That's down 2 over 1. I get -2. Some people say, didn't you tell me every time to do slope to right? I think you could totally get away with this one. But if you want to do, the slope formula, then you would do 4 minus 0, subtract the y's of this point and this point over, subtract the x's the same way, 2 minus 4. So you get 4 over -2, and you get -2. So if you want to be extra sure, you could put that slope formula in there. So what are the points? The points are each one of these was +1. Remember, don't you dare just put g of 3 equals 3. G of prime equals 2. Like, you have to show from the given how you got it. So all that has to be in there. Find the intervals from 0 to 7 where the graph of g is both increasing and concave down. Here we are back at curve sketching. So let's think about this. I'm going to think first, and then I'm going to write it out. Well, what does that mean? Well, if g is both increasing and concave down, let's think for a second. One thing, I have to make sure I understand that, again, g prime is equal to f. So what they gave me was f, which they gave me is g prime. So I have to defend with g prime. What would have to be true about g prime for g to be increasing and concave down? Wouldn't it be true that, and you're not going to write that, I'm just going through a thought process. Wouldn't it be true that g prime would need to be what? G prime would need to be positive for g to be increasing. For g to be concave down, then that means g double prime would have to be negative, but I have to defend with g prime, so that would mean g prime would have to be decreasing. So what am I looking for? That was a lot. What am I looking for on this graph, which is g prime? I am looking for positive values, so above the x-axis, and decreasing. Where does that happen? That happens right here. These are the values that have positive y values, so g prime is positive, and g is decreasing. So my answer, I would say g is increasing and concave down from or on 2 to 4 since why? Since g prime, and I like to say which equals f, even though I might have set it up there, that doesn't take too long to write, is positive and decreasing. What are the points? The points are getting the right interval and saying the right justification. Letter C, For how many values of C between 0 and 3 is G prime of C equal to the average rate of change of 7/3? Okay. I think the funny thing is I think this question, I bet you maybe overthought a little bit, because it is the existence theorem. You're like, oh, okay, what theorem do I need to use? Because that's been every one that we've done so far, kind of like this. But what's funny about this guy, it's like, it's really such a simple question. For how many values of C between 0 and 3? So let me, on my graph, I'm just reading carefully. Is G prime of C, this is G prime, equal to the average rate of change of 7/3? I mean, my gosh, they gave you the average rate of change. They just say, forget the whole average rate of change, is equal to 7/3. I mean, that you didn't even have to calculate that. You could have, and let me just be clear, because they could have been mean on that, and figuring out the average rate of change, but they gave you that. So okay, so here's the deal on this one. When this question is saying, where is G prime of C equal to 7/3? Well, this is G prime. 7/3 is what? 2 and a little bit. Boop. How many times is it hitting that line? Well, twice. So my answer, I'm just going to say there are two values where G prime of C is equal to 7/3, since, and I'm going to say it again, G prime of C equals F of C, and F intersects, I'm going back to the given, sorry, that's messy, intersects Y equals 7/3 twice between 0 and 3. That one was so, yeah, it's almost like it's so easy, it was hard. So you got 1 point for two values. You got 1 point for saying the reason. If you said there was at least one, like, oh, there's at least one C, and used the mean value theorem and said the words at least one, then you would have gotten 1 point, but you could actually find those values and see that it's actually 2. Last one. Find the x-coordinate of each point of inflection on the graph of G on the interval 0 to 7. Justify your answer. All right, what do we know? We know G has a POI at, I'm going to leave some space there, since what? Again, can you justify with the second derivative? No, because you were given the first derivative. Since G prime or F does what? Changes from increasing to decreasing. I can't write anymore. Changes from increasing to decreasing or decreasing to increasing. So where does that happen? Where does your graph of G prime change from increasing to decreasing or vice versa? I'm going here, I'm increasing, then I go to decreasing, so that's at 2. I'm decreasing, 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 and then I increase. So what are my two answers? At x equals 2 and x equals 5. And those are my two. Point count, you got 1 point for doing 2 and 5 only, and then 1 for the justification. So if they listed 2, 5, and 4, you didn't get, of course, that point. All right. I don't have an average on that one. That one was given. I don't know why I don't have an average on that guy. But okay, there you go. There are all the free response. Lots of good things. And hopefully you could see where you can add some points and write a few more things down that you can get some more points on the AP test. All right. Peace out.